Let us take one more example on linear transformation. The question is, given the transformation y is equal to 2, 1, 1, 1, 1, 2, 1, 0, minus 2 into x1, x2, x3, find the coordinate x1, x2, x3 in x corresponding to 1, 2, minus 1 in y. So in this example, y is a linear transformation of x. Here, the values of y1, y2, y3 are given, which are 1, 2, minus 1. We have to obtain the value of x1, x2, x3. Here we use the property of linear transformation and we'll try to find out the values of x1, x2, and x3. The given transformation is y is equal to ax or y is equal to 2, 1, 1, 1, 1, 2, 1, 0, minus 2, x1, x2, x3. So clearly y can be also written as y1, y2, and y3. This is called y, variable y. This is linear operator or a, and this is the second variable x1, x2, x3. Here, y1, y2, y3 are represented in terms of x1, x2, x3. Therefore, y is called the linear transformation of x1, x2, and x3. And y is called the linear transformation of x, and it is represented by y is equal to ax. Now consider determinant of a. Determinant of a is 2, 1, 1. Determinant of 2, 1, 1, 1, 1, 2, and 1, 0, minus 2. Let us try to find out its determinant. 2 into 1 minus 2 minus 0 into 2 minus 1 into 1 minus 2 and minus 1 minus 1 minus minus 2, 1 into minus 2 minus 1 into 2. And the last one is the, leave this row and this column. 1 into 0 is 0, minus 1 into 1 is 1. Here, 1 minus 2 is minus 2. 0 into 2 is 0. 1 minus 1 into minus 2 is minus 2. 1 into 2 is 2. 1 into 0 is 0. And 1 into 1 is 1. So we are getting 2 into minus 2 minus 0. Minus 1 minus 2 minus 2. Plus 1 into minus 1. Again, if we simplify, 2 into minus 2, minus 1 into minus 4, and 1 into minus 1. Minus 2 into minus 2 is minus 4. Minus 1 into minus 4 is 4. And 1 into minus 1 is minus 1. So this minus 4 and plus 4 will cancel. We have the answer minus 1. Since the determinant of A is not equal to 0, therefore, the given matrix is regular, and we can also say that regular means non-singular. What is the meaning of singular matrix? If determinant of the given matrix is 0, then it is called singular matrix. Since its determinant is not equal to 0, so it is non-singular matrix. Since the matrix is non-singular, means its determinant is not equal to 0, therefore A inverse exists. Therefore A inverse exists, which is given by, what is the formula for A inverse? It is nothing but the adjoint of A divided by determinant of A, which is equal to 1 upon A, 1 upon determinant of A, A11, A12, A13. These are cofactors and the whole transpose of the cofactors of the given matrix. I think we have already done in the previous classes. Let us try to calculate the value of A11, A12, A13, A21, A22, A23, A31, A32, and A33. Here A is equal to this A11. What is A11? It is nothing but we have to leave this column and this row. And -1, A11 means -1 to the power 1 plus 1. And if we leave this row and this column, what is remaining? 1, 0 and 2 minus 2. If we simplify it, -2 minus 0. And -1 to the power 2 is 1. So -2 minus 0 is -2. Similarly, A12 -1 to the power 1 plus 2. So -1 to the power 3, which is equal to minus. And this is A12. We are leaving this row and this column. 1, 1, 2 minus 2. 1, 1, 2 minus 2. If you multiply, if you simplify this determinant, 1 minus 2 is -2 minus 2. Minus of -2 minus 2 is, which is equal to minus of -4 and gives us 4. A13 -1 to the power 1 plus 3. Again, this is A13. So we have to leave this row and this column. 1, 1 and 1, 0. 1, 1, 1, 0. So 1 into 0 is 0. 1 into 1 is 1. And -1 to the power 4 is again plus 1. 0 minus 1 is equal to -1. A21. A21, this is A21. So leave this row, and this column. 1, 0, 1, minus 2. 1, 0, 1, minus 2. If we simplify, we get 2. A22. Similarly, we are able to get the all A22, A23, A31, and A32, A32, and A33. After getting all these values, we have to substitute all these values in this equation. So A inverse is equal to 1 upon -1 because determinant of A is -1. -2, 4 minus 1, 2 minus 5, 1, 1 minus 3, 1, whole transpose. So if we take the transpose means the row, this row will be converted into column. The second row will be converted into second column. Third row will be converted into third column. This is A inverse of the given matrix. Let us multiply with the minus sign. So if we multiply minus sign, this -2 will become +2. So all negative will become positive and positive will become negative. So this is -2, -1, -4, -1, -1. And the negative part will become plus. This is the inverse of the given linear transformation. Now let us go to the next part. Hence we have y is equal to ax. Since A inverse exists, so let us multiply, let us operate A inverse on both the sides. Let us operate A inverse on both the sides. So A inverse y is equal to A inverse A into x. We know that A inverse A is equal to I. A inverse y is equal to I into x, and I into x equal to x. Therefore, x equal to A inverse of y. Now, what is the value of x? X is nothing but x1, x2, x3. A inverse into y1, y2, y3. And we have already obtained the value of A inverse. So let me just put the value of A inverse. Now, y1, y2, y3 are also given. It is 1, 2, -1 in the example. Now we have to multiply these two matrices. So 2 into 1 plus -2 into +2 plus -1 into -1, the first row. Similarly, -4 into 1 plus 5 into 2 plus 3 into -1. Similarly, 1 into 2 minus plus minus 1 into 2 plus minus 1 into minus 1. And if you simplify it, 2, 2 into 1 is 2, minus 4 plus 1. 2 minus 4 plus 1. Similarly, minus 4, 10, and minus 3. And 1 into 1 is 1, minus 2 plus 1. 2 minus 4 plus 1 means 3 minus 4 is minus 1. Minus 4 minus 3 is minus 7, plus 10 is equal to plus 3. 1 plus 1 is 2, minus 2 is equal to 0. Therefore, the values of as the coordinate in x is minus 1, 3, 0, corresponding to the coordinate 1, 2, minus 1 in y. This is our answer. Thank you.